going to take a glimpse at some of the new capabilities of XSI's Gigapolygon core architecture. As model sizes and scene sizes increase, as well as complexity, XSI can now handle this data not only now, but also as the future requirements demand. Currently most people work on a 32-bit application, but XSI now offers a 64-bit application and all the goodness that comes along with that, including increased RAM capabilities. But let's start with the simple things, such as being able to do display. Here we have 111,000 triangles on this head. If I were to go into my geom approximation and hit the plus key, you can now see I'm up to 445,000. And here I'm going to hit plus again, and we're going to jump to 1.7 million. Okay, I'm going to grab my tweak tool with proportional modeling, and you notice how I can start to still interact with my character here with only a tiny bit of slowdown on the interaction, and that's at nearly 2 million triangles. Now of course I can hit plus again and just start to have just show you the impracticalities of being able to display 7 million triangles here. And again, I can still grab my part of my mesh and still start to pull it around. So still working on my 7 million triangles, but of course it's now really starting to get quite dark and quite light when it's selected. So we have optimizations inside here to be able to do turn off all the triangle display, and we can do things like just the simplified subdivided wireframe display. I can take it up one more notch to around from 7 to around 30, 28, something like that, and just show you one more time for the number of triangles to continue on my interaction. So 28 million is probably, just for now anyway, you're not going to probably get much past that, certainly in the interaction stage. So this will show you that it's going to handle any geometry which comes in from other products, that's for sure. So the next level of display, rather than just continue on my points, is to go to the optimization to things like bounding box. So just watch this triangle count up here as I start to have a play. So we're at 28 million. I'm now going to press my geom approx button again. I think I might have even reached my limit. Yep, I have. So in the UI we actually only go to level 4, which is probably quite sensible. I'm now going to go to level 5, so that's 114 million triangles. 6, half a billion. And finally, Gigapolygon, we're going to have a look at 1.8 billion triangles in my scene. Well, interaction on this is prohibitive, really. So, but what isn't going to be unusual, not only in a 32-bit app, but also a 64-bit app, is always wanting to render more and more and more. Inside XSI, you'll find in the render options, you'll now have heavy scenes and model optimization, and this is really for scalability, especially for the future. Now, here are the standard defaults which you can work with every day. There's also a little quick set mode to optimize it for not only large scenes but also large models, and this is designed so that when we start to do our rendering, that it will in fact render, and rather than just run out of memory, throw errors, and just not give you the chance to even think about rendering it. Maybe even rendering it in chunks. It's now possible to render it in one go. So grab the render region, and I'm now going to draw a region around my whole character. So this is 1.8 billion triangles. If you look down here, I'm going to just move this up so you can now see the amount of RAM and capabilities. Each of these little tiles, by the way, is going to work. One of those CPUs is going to grab one of those tiles and give it its best shot at rendering a part of the object. Let's just move this down a bit. There we go. You can see. Now this line here is also obviously a reflection of the amount of RAM it's going to be using. Now the smaller the tile size, the smaller a CPU can actually work on a smaller number of triangles. If you have a larger tile size, then one of the CPUs is going to try and fit that much more triangles in one go, and what's probably going to happen is that it might find that it's going to start reaching its memory limit Now currently we have the physical memory limit of the machine, and here in this dialog box is the mental ray memory limit. If that memory limit is going to be hit, then what XSI can now do is actually be very clever by being able to just offload part of that memory and call it back later. Now when you're dealing with 4 CPUs, it's obviously greatly increased in performance, and 2 CPUs is still going to be exactly the same thing. It's going to be clever about when it needs memory and when it doesn't. What I'm now going to just do is up. You see the aliasing. Well, even with this level, we want to be able to make it look good. So inside my aliasing settings, I'm now just going to increase it. And you'll now see it's going to start again as I do my changes. And it's still working with its memory limit. So dual core, it's just a phenomenal increase in the capabilities of what we'll be able to render. And here, rendering interactively as well. And as you notice, do follow this line. Every time that it has any sort of difficulty, it's just going to offload a little and then come back to a little later. This might add a little bit of time to the renders, but what it really means is when it loads into XSI, it will render out. If we go back to our optimization and have a look at this, well, maybe we don't have, in this case, 8 gigs of RAM. I'm actually going to show you a little bit more practical example of what we mean by being clever about RAM usage. I'm actually going to specify a limit. So what's you might have 2 gigs on your machine. You might have the physical limits of 32-bit are now 3 gigs. So I'm going to actually limit mental ray to only using 2 gigs of RAM here. So I'm going to do this again, and I could increase the tile size. Let's just increase it a little bit like so, and maybe I'll just increase the mesh splitting factor. So this is another excellent way in which it deals with the number of triangles in one smaller area. Again, another excellent example of how we've been able to optimize XSI together with XSI rendering to be able to handle such phenomenal amounts of triangles. So off it goes again, and now keep an eye on this memory limit here, is that it's going to be the physical memory limit of the actual OS, but it's never going to exceed 2 gigs inside of its rendering capabilities. Notice again it's going to go at 100% up here, and off it goes with the tile size starting to do its render. So do bear in mind that obviously playing around with these settings, you'll be able to optimize it so that it's going to achieve and follow exactly what you ask for in terms of physical memory capabilities. And as these memory capabilities improve and increase together with the amount of cores that you have, then XSI is just going to take advantage of it, and you'll be able to up this and up this until you hit your lovely unlimited magical number. So you see down here how it does a little bit of offloading. It's going to hit that memory limit and go, no, I'm not going to run out of RAM. I'm going to keep everything into RAM. I'm not going to go to swap space. I'm going to offload it and call it back a little bit later. And I'm going to throw open a CPU to work on another part of the object or scene. Extremely clever, extremely practical, and this is only found in XSI. I'm going to interact with a scene of really quite extraordinary size here. Although it's only 2.5 million triangles, this scene contains 1001 club bots doing their soon to be famous club bot rave. Each individual club bot has its own unique texture. Number 368, 562. Each individual texture is 512 by 1024. That's about half a gig of textures. Inside here, clubbot 0, clubbot 1 to clubbot 1000. Each of these has its own animation mixer, each of these has its own motion capture, and each of these has a hell of a lot of keyframes, including number of channels that's being driven. If we start to orbit around it, it's not a problem. But what really stands out is the ability to be able to render. This is using XSI's Gigapolygon core architecture. Whether or not it's 32-bit, or in this case a 64-bit, be able to memory manage any scene, whether or not your physical memory limit is a gig, 2 gigs, 3 gigs, or in this case using a dual core, 8 gigs. Now this is a scene with ray trace shadows, naturally, but just look at the speed that it's been able to do. And it's also very clever about how it does it, because it's only going to push what it needs to inside the scene, and it will offload anything where necessary. It really is quite remarkable. If I were to go to here, you can see we're working with 5 gigs of RAM.